Hello, I am David W. Parker. This is Programming Today I Learned, WebGL Series, Episode 75, Lighting Part 4, and we're going to be looking at transformations today. So, what you may have noticed in previous episodes is when one of the cubes is transformed, the lighting is a little bit off, and even though we're providing the normals for surfaces, what we're not doing is providing a way for the transformed cube or transformed object to have the proper normals given the position of the light. So what we're going to end up looking at today is a normalized matrix, and I'm not going to go into the specific maths today, and maybe I will in a future episode, but what you need to know is that if you take your model matrix that's provided for each object and invert it and then transpose it, then that'll give you the normal matrix for that model matrix. And by passing that into your shader, you'll be able to compute what you need to for light to work properly. This is such a common thing to invert and transpose that most libraries include a shortcut to do it. And you'll see a lot of examples out on the web if you go look for the inverse transpose matrix to determine lighting. So let's go ahead and just take a look at how it's done in code. So we've added some stuff back so that we can drag and move our objects around. And we also have this angle here for that as well. And so let's scroll down. We will get to the meat shortly. Again, we have rendering and reading states per the previous episode. And we have multiple cubes if we want to uncomment those. But now let's go ahead and see what's going on. So you can see here that for every object, we're going to go ahead and create a new model matrix, and we're going to go ahead and give it the rotation provided, and this is given that one of our previous episodes where we talk about rotating and moving objects. And then we're going to go ahead and multiply that out, and that's going to set the MVP on that as well. And then during rendering, we're going to go ahead and only do this during rendering, which is what we need to have for the lighting. So what we're going to do is we're going to use mat3, so we only need a 3x3 matrix here. And we're going to go ahead and grab the normal from a mat4. So we're going to go ahead and create a new one, and then we're going to provide the object state which is the new up here, to that. And then we're going to go ahead and set that in the uniform here. Now that's the same thing as doing this code here. Let me uncomment that so you can see it easier, which is inverting a 4x4 given this state, then transposing it, and then setting that as a 4 FV. So you could do this, but this is just a shortcut method. And like I said, most libraries provide a shortcut method because this is such a common thing within applications now to do that. So if we go ahead down here, you can see here's all the code that we need for actually rotating. Nothing special going on there that you haven't seen before. Now in our vertex shader, you're going to have this uniform normal matrix 3. Like I said, if you do the longer version, you'll have a matrix 4 here. And then what we're going to do is normalize this, like we did on the previous episodes, with just the A normal, but this time we're going to be multiplying the normal matrix times a vec3 of the A normal. And that's going to end up with the normal that we'll use to compute the in normal.light. So that's really it. If you go ahead and get the 4x4 in, you're going to have to cast the whole thing, of course, so that you can normalize it to become a vector 3 as opposed to a vector 4. But that allows us to go ahead and have a transformed object, whether it's translated, rotated, etc., and have lighting show up appropriately. So now when we rotate this, you can see that the lighting stays appropriate on this front side. Now, of course, if we move our eye position, we'll still see the darker side because the light has been rotated around with that, since our eye position is different. But that's how you're going to fix the lighting, though, for the model matrix, is to make sure you compute the normal matrix. That's it for this episode. If you like what you saw, go ahead and subscribe, like this video. This will help me a lot on YouTube. Share it on social media if you will. Follow me on Twitter, and go to ProgrammingTIL.com and sign up for my newsletter. Have a great one.